So, what does this golf club and this toy shark have in common? Well, one is that I'm about to throw them. The other is that they both have their own gravities. Gravity, by definition, is a force. Not by definition, it pulls everything to their centers. Everything. Gravity affects everything all of the time. It is universal, be specific. Now, I'm going to get into some more details about gravity. Gravity is like a fabric. We had a demonstration of this in class with the elastic material and the round spherical objects that we dropped on it. I'm going to use the Earth and the Sun as an example. However, the Earth and Sun are just so heavy that we cannot really comprehend them. So, I'm instead going to use a ping pong ball for the Earth. Ping pong ball is relatively light, about 27 grams. Now, the Sun is 330,000 times larger than that. So compared to this ping pong ball, the Sun would be a grizzly bear. Now, if we can imagine a trampoline, alright? You have fun, you bounce on the trampoline, it bounces you up or whatever. Now, when the grizzly bear, it sits on that trampoline, it causes it to elasticate and let the grizzly bear sit there. It creates kind of an indentation in the trampoline. Now, this happens if you have a really stretchy trampoline. It'll happen with this ping pong ball too. It'll sink in a bit. This would be the gravitational field of the grizzly bear and the ping pong ball, which in this case are the Sun and the Earth. Now, since the Sun exerts such a gravity that it creates that sort of funnel thing, the Earth, it's on that funnel, and its inertia is pushing it forward, but then it falls in the funnel. And it's getting pushed forward, and it falls in the funnel. This is how gravity keeps our planet in orbit with the Sun. Without this gravity, it'd just go flying, like that, due to the inertia of the planet. However, thank goodness we have gravity to keep us in place. Gravity. What else is there about it? Well, as I've said, it affects everything. Not just our planet, alright? This big, beautiful globe that we live on, this is not the only thing affected by gravity. It affects, well, this empty 7-Eleven smoothie bottle as well. Now, that is made out of glass. I just threw it and it cracked on the floor and got glass everywhere. My dad's not going to be happy about that, but also that allows me to segue into gravity strengths. Now, I have this neat little notepad because, well, it's neat and it's little. And it has a cute little puppy and a kitty on it. Yeah, anyways, so I also have the default gravities of some important bodies in our solar system. Excluding the Sun, which I'll put on screen right now. It's 9.8 meters per second squared on Earth, 1.6 meters per second squared on the Moon, 3.7 meters per second squared on Mars, and 8.87 meters per second squared on Venus. Now, this is just how gravity pulls you down. Your weight is indeed affected by this because this force, this 9.8 meters per second squared, is pulling you into the Earth, alright? This is you, this is the Earth, you are being pulled into the Earth. Now, that force that you're being pulled with is your weight. Let's say you weigh about 120 pounds. That 9.8 meters per second squared that you're being pulled to the Earth with, the amount of force that totals to is 120 pounds. Now, what else is there to talk about gravity? Gravity does all this neat pulling stuff, but it isn't just limited to the planets, and the Sun, and the stars that we see, and everything else. It also affects the universe itself, because at the start of the universe, according to the Big Bang Theory, all that stuff just appeared. And it all just started clumping together. And all of that eventually started becoming stars and galaxies. What was the force that pulled it all together? Gravity. That's right. Gravity very much, according to the Big Bang Theory, helped us create the universe. And gravity, it still pulls our universe together to this day. As a matter of fact, here's an analogy. Let's say you have a ball of dough, and you're baking raisin bread. Now, this ball of dough will represent the universe, and the raisins will represent galaxies. Now, the universe is expanding. But the thing is, the galaxies themselves aren't moving. The dough that you've placed the raisins in to bake your raisin bread, it expands, alright? It's getting all airy. It's expanding. The raisins themselves aren't moving, the dough is. Gravity, as I mentioned, is supposed to counteract this force. It's supposed to create an equilibrium of sorts. However, this stupid thing called dark energy is making it all go to waste and is just expanding the universe anyways. Alright? That dough that the raisins are in, it's just gonna keep expanding. And it's gonna keep expanding, and keep expanding, and keep expanding. Forever. Now, this dark energy theory, it's just a theory. We really do not know why gravity isn't just pulling everything back together. Now, gravity, it seems so important, but as we all know, it was only invented some 500 or so years ago when an apple fell on Newton's head and he came up with the formula of the gravitational constant times the masses of two objects over the distance between them squared is the gravity between them. What did we have before this? We had nothing. That's right. People from all that time ago thought that planets and the sun and stars all followed just a set natural movement. This was because they originally thought that movement had to be caused by stuff directly pushing each other. Now, from a modern standpoint, gravity seems like a pretty given thing. Like, there has to be a reason why stuff falls, there has to be a reason why all these planets orbit the sun. But people thought everything orbited the Earth back then. And they had really weird minds. And this is why these ideas that stuff just moved naturally on their own was so common back then. People didn't know what else to believe. They just believed stuff that smart people said in the past. Now, no offense to ancient scientists, they were very smart. But they just weren't quite there yet. Now, gravity, it's a very special force, alright? It pulls us to the Earth. It makes us not go fly into space and die. It's overall just very helpful. But compared to other forces, it's really weak. Quadrillions of times weaker. That's a 1 with 15 zeros after it. Alright? 15 zeros. These other forces are the strong and weak nuclear force and the electromagnetic force, which mainly affect the properties of atoms and quarks and other miniature stuff like that. So, if you're going to leave this lesson with anything today, here's what it should be. Gravity is a force. It pulls everything to an object's center. It affects all objects all of the time. It is one of the 4 most important forces in our universe. It is also the weakest of those 4. Gravity also pulls our universe together. As a matter of fact, it even did so fully in the past. Thank you for your time and your consideration. I will now show on screen the websites that I used to gather this information. Have a good rest of your class.